welcome to my skills versus capacities vlog. A skill issue is a limitation caused by poor motor control, whereas a capacity issue is a limitation caused by a structural defect such as strength or mobility. The background of this athlete is that he's got a history of bilateral chronic ankle instability. He's had a recent right-sided grade 2 ATFL and CFL sprain. This research by Price et al. Investigated the injuries over 2 seasons in English academy footballers. Out of the 3,805 injuries, 20% of them involved lateral ankle sprains. Here is some footage of the athlete completing an A-skip. This athlete has generally good mechanics and is able to achieve triple extension prior to takeoff. He also has a positive knee drive with the swing leg close to the optimal 90 degrees. The athlete also pre-tensions his ankle into dorsiflexion prior to making foot contact. However, the athlete doesn't clear the ground very well at takeoff and has poor vertical oscillation of the centre of mass throughout the drill. This could suggest that the athlete has poor stretch shorten cycle and stiffness capabilities in the calf complex, which are required during initial foot contact and takeoff. This indicates that the athlete has a strength capacity issue. Here the athlete is completing a pogo exercise to assess his ability to utilise his stretch shorten cycle of his calf complex. Here is our academy plyometric screening document. This categorises our athletes into either low or high flight times and fast or slow contact times. The standards seen in each category are based on data from under-18 Premier League Academy players over the past 2 seasons. To assess his stretch shorten cycle capabilities, we completed a TEM5 test. The TEM5 was completed to give a reactive strength index score looking at his flight time and contact time. This study by Stratford and colleagues report that the TEM5 has an increased reliability obtaining RSI data in comparison to a drop jump. In addition, a strength of the TEM5 is that the TEM5 also overcomes issues such as standardizing and controlling actual fall height from a box, which is a significant limitation associated with drop jump testing. Therefore, this is why we ended up using the TEM5 in comparison to a drop jump. Here you can see his average flight time is over 500 milliseconds and his contact time is longer than 200 milliseconds. This indicates that the athlete needs to work on his calf capacity as well as his stiffness. This ankling exercise works on ankle stiffness, and the aim is to prevent the heel on the stance leg from dropping. The aim of this exercise is to execute a quick back foot contact whilst producing vertical force, which is an essential component during top flight speed. The amplitude and direction of movement in this exercise is kinematically similar to the A-skip, and therefore it could be argued that this exercise will have a good crossover to the A-skip performance due to the dynamic correspondence between the two exercises. This study by Ramirez et al. Shows that plyometric jump training improves reactive strength index in youth footballers aged between 10 and 16 years. These findings can be transferred to this athlete as he fits within the age criteria. However, the findings should be interpreted with caution as the participants in this study are recreational footballers. Therefore, a study involving Premier League Academy footballers would have greater transfer to this athlete. During this A march, I have cued him to smash the glass with his knee during his swing phase and hammer the nail into the ground during foot contact. Here you can see the athlete is able to produce greater force and have a greater vertical oscillation of his centre of mass, hitting superior triple extension mechanics and superior stiffness in his calf complex. The background of this athlete is that he's recently been recruited to the academy, has a low training age, and is inexperienced with speed drills. Here is a clip of the athlete completing an A-skip. This athlete has suboptimal triple extension, poor dorsiflexion of the swing leg, which doesn't allow him to pre-tension the plantar flexor muscle group. This can be seen here during the stance phase where the contact is made with a flat foot. Due to the low training age, adequate dorsiflexion range of movement, and calf complex strength, it is suggested that this athlete has a skill issue when completing an A-skip. This is further supported when you see this athlete complete a drop jump and pogos. He pre-tensions the calf complex, which allows him to utilise the stretch shorten cycle and produce greater vertical ground reaction forces with a good flight and contact time. Here you can see the athlete has a greater than 500 milliseconds flight time and less than 180 milliseconds contact time, which results in an excellent RSI score. Due to this athlete having excellent jumping capabilities, the main things we worked on were high repetitions of the A drill to develop greater motor patterning and producing force in positions which he hits during high speed running. This run-specific isometric exercise puts the athlete in an optimal triple extension position at ground contact where he is cued to produce as much vertical force as possible. The amplitude and direction of movement is kinematically identical to the A-skip, and the aim of this exercise is to get positive crossover in both his mechanics and force production capabilities due to the similarity in positions. Following the exercise intervention and cues of smash the glass during the swing phase and hammer the nail into the ground with the stance leg, the athlete is now able to hit superior mechanics as seen in this still shot with a vertical stiff trunk, triple extension of the stance leg, and a more optimal knee drive. The background of this athlete is that he's recently been recruited to the academy, he's got a low training age, and he's inexperienced with change of direction drills. The athlete has a hesitant approach to the cone, and when reaching it, the lower limb is in an internally rotated and adducted position known as dynamic knee valgus, which is known as a vulnerable position for field athletes. Recent research by Collins et al. Supports that dynamic knee valgus is a biomechanical risk factor for ACL injuries. Although their study involved female footballers, the results are transferable to male populations likes of this player. The stepping leg is in a good position outside the athlete's base of support, and the trunk position is reasonable as it faces towards the direction of travel and along the lateral force vector. During this sagittal plane view, the athlete's weight is back and he overstrides with his centre of pressure out in front of his centre of mass. This is likely a compensation strategy to give himself more time for the lower limb muscles to produce force and help him decelerate before his body changes direction. Here the athlete is completing a slow eccentric split squat and a reverse Nordic with good form, which requires high levels of eccentric quadricep strength. Good strength capacity coupled with low training age supports that this athlete has a skill rather than a capacity issue when changing direction. We worked on transverse plane control and transverse plane strength in the gym. Research by McCormick et al. Reports that completing strength and stability exercises in multiple planes has a positive correlation in change of direction speed. We also completed high volume of 90-degree cuts to provide the athlete with greater change of direction exposure, helping to improve his motor adaptations. Along with high volume of 90-degree cuts, cues such as stay tall, push the ground away, and drive the trunk towards the direction of travel were used. This resulted in superior mechanics with the trunk more side flexed and rotated towards the target, and an externally rotated hip on the stance leg, creating a more optimal length tension relationship for the glute max to produce force along the lateral force vector. This athlete has had a left ACL reconstruction and it's his first exposure to change of direction drills. Here is a clip of the athlete completing a 90-degree cut. Here you can see the stepping leg outside his centre of mass with a neutral position at the hip, allowing him to create greater lateral force production due to the glute max being in a more optimal length tension relationship. The athlete's trunk is rotated and side flexed towards the direction of travel and the lateral force vector. Although the athlete has reasonable mechanics during this cut, this slow-mo shows that the athlete has poor ankle stiffness when pushing off and the knee is close to terminal extension before the hip is extended. This indicates a poor co-contraction between the lower limb musculature. This is supported when putting the athlete in a position where he has to co-contract his lower limb muscles. As you can see, he snaps his knee back prior to extending his hip, which is a suboptimal approach, resulting in less horizontal force production. During this sagittal plane view, you can see the athlete's centre of mass is significantly behind the centre of pressure during final foot contact. This is likely a compensation for poor eccentric strength qualities following his left ACL reconstruction, which involved a patellar tendon graft. Reverse Nordics were part of his program to improve his eccentric strength deficits, which will help him decelerate when doing his change of direction maneuver. Rotational trunk exercises and lateral bounds were also included in his program to help with transverse plane control and strength and lateral force production. Following his individual strength program, he is now able to co-contract his lower limb musculature more efficiently with his hip extending before his knee. After completing high volume of 90-degree cuts alongside his strength program, he now has a reduced centre of pressure to centre of mass distance with his final foot contact prior to the change of direction. This allows the trunk to be more upright with a knee flexion angle close to the optimal 90 to 100 degrees, and the trunk is rotated towards the line of travel and the lateral force vector. Optimal mechanics involving an upright trunk facing the direction of travel with knee flexion angles of 90 to 100 degrees during the penultimate foot contact is supported in this study by Dos Santos et al. Here you can see that he approaches the change of direction task with more intent, indicating increased confidence, and he's able to produce greater lateral forces, resulting in a more efficient and faster 90-degree cut.